Right. Okay. So the discussion today is gonna be about waves. Okay. So the very first thing what I have to ask from you, what do you know as a wave? What is a wave? Then ape physical classes lama ek uttar dona, right? When I ask them what is a wave, what do they know about a wave? They came up with some examples, right? They said uh, waves are formed on water. We call them as ripples, right? Ripples on water, right? Okay. They said that they were waves. They knew them as waves, right? And then they even came up with the word sound is waves. And then some of them said geological waves, like when you talk about earthquakes, the energy transfers through earthquakes on the ground through waves. Yes, even some of them told about shock waves, right? They came up with different ideas about waves. So the thing what you have to understand, right, about a wave is then online I'm not going to waste time like letting you to talk about waves. So these are some examples for waves. You should be familiar with these all answers, right? And when you know about a wave, when you talk about a wave, the very first thing what you have to understand is wave waking monada karanne. What does the wave do? Wave waking basically karanne lamai energy ka propagate karane. From one point to another different point, energy is propagated through a wave. That's what a wave does, right? For a wave, main function, it carries energy from one point to another different point. So that is mainly what a wave is. So I hope you have get the tute copied down, and then let's quickly write the definition for this wave. For this part, let's quickly write what is a wave. Uh, let's write the description and then I'll just explain it what it really means, right? Wave. What's a wave? A disturbance which propagates. A disturbance which propagates. A disturbance which propagates from one point. A disturbance which propagates from one point to another point. From one point to another point. From one point to another point. In a particular medium, within brackets, solid, comma, liquid, comma, gas, a disturbance which propagates from one point to another in a particular medium within brackets, solid, liquid, or gas, close brackets, or through vacuum, is called a wave. Okay, that is what the definition for a wave is. So if you go through this definition, the definition tells you a wave is a disturbance which propagates through a material media, right? Material media can be observed in three physical states: solid material media we have, liquid material media we have, and even gaseous material media we have, right? So we have all three physical states of states for media. Media means any medium, right? We can then now when we are on Earth, like if I spread my arms and rotate, I feel that air particles collide on my arms. So I am in a medium of air, right? So my entire body is surrounded by a gaseous medium. So if you jump into a water, you are surrounded by a liquid medium, right? So likewise, medium right? So the definition of a wave says it's a way how the energy propagates from one point to another through a material media. The material media could be solid, liquid, or gas, or through space. Or through vacuum. Okay, or through vacuum. Okay, so then what you to understand from this definition is a wave can travel through two different places. It can travel through material things, and the waves can also travel through vacuum. Vacuum can space. Okay, අපි කතා කරමු පොඩ්ඩ කතා කරමු waves ගැන. But before that, let's just talk about these waves. මම පොඩි example එකක් දෙන්නම් මේ definition එකට support කරන විදිහ example එකක්. If you can remember, we get energy to the earth by a natural energy resource called sun, right? So if this is sun, right? If this is sun, and if this is earth, now just imagine this is earth. You know that the earth is surrounded by an atmosphere which is filled with gases, right? So this entire thing is filled with air, right? This entire thing is filled with air, and this whole thing is a vacuum, right? This whole thing is a vacuum, which we call as a space, right? Space is a vacuum. That means there are nothing, no particles in between the sun and the atmosphere of the earth, right? So, but still, if you could imagine, if you could think, have you ever, now we experience daily, right? From the sun, there are sunlight reaches the earth through this vacuum, through this empty environment, through this space, and this sun rays can also travel towards the crust of the earth through air, right? So these sun rays are a form of energy, right? It comes into us as a wave, right? And these waves, right? These waves can actually travel through space, which is a vacuum. There are no particles, and also these waves can travel through a material media called atmosphere, which is a gaseous state, right? A wave can travel through both a material medium or even through space, even through vacuum, let's say, right? Particles නැති තැනක උනත් සමහර waves වලට යන්න පුළුවන්, right? So when we are talking about waves, we have a classification. We will learn about this classification, and then we will be okay with what waves can travel through vacuum and what waves cannot travel through vacuum, right? Okay. So basically, what you have to understand, the definition says waves are a way of transmitting energy from one point to another point, sometimes through material media, or even without a material medium, like the space, right? So that's what the definition is, okay? And then let's quickly go through this small definitions and statements what is printed over here. So it says it's an important property of a wave is that it carries energy from one point to another. That's very important. So you need to highlight it. That's the very most important part of this lesson. A wave carries energy from point to a point, right? Next one. The energy transmission takes place in a way that the particles are not transmitted in the medium between two concerned points. So you need to highlight this thing as well, because that is also an extremely important point. Very important. So here this point, may point එක කියන්නේ, when the waves are traveling through material media, right? අපි wave එකේ definition එකේ පොඩි කැලලක් තියෙනවා explain කරන්න. ඒකත් මම මේකෙන් මාර්ගන explain කරන්න. ඔයා දකින්න ඇති it's a disturbance propagates through a media කියලා තිබ්බා. මම මේ disturbance කියන කැලල define කරන්නම් මෙතන ඉන්න. Right? එතකොට මේකේ කියනවා මේ definition එකේ කියනවා මේ statement එකේ කියනවා when a wave propagates from one point to another, only the energy transmits, but material medium එකේ in the particles are not moved related to concerned points, right? Now this says, the second statement what we were talking about says, when a wave is propagating through a material medium එකක් අස්සෙන් wave is propagating through a material medium එකක් අස්සෙන්, ඒ කියන්නේ physically අල්ලන්න පුළුවන් material medium එකක් අස්සෙන් wave එකක් propagate වෙනකොට wave එක විදියට propagate වෙන්නේ points දෙකක් අතර energy එක විතරයි, but not the particles, right? Simply it's like this. Just imagine you take a rope, okay? You take a rope, and then can you make it a little wave on it? Yes, you can, right? අර අපි පෙරහැරවල වල කස එහෙම ගහන්නෙත් එහෙමනේ. අර මෙහෙම කරලා චකාස් ගාලා ගහනවා. එතකොට අර අපි දෙන එනර්ජි එක ඔය rope එක through යනවා. Just imagine මෙන්න මෙහෙම කරන්නකො, මෙන්න මෙහෙම imagine කරන්නකො. Like you're taking a rope like this, and then you're making a wave on it, okay? You're making a wave on it, right? So you're making a wave on it, okay? Perfect. For this making a wave, to make a wave like this on this rope, what did you do? Imagine this was your hand, You moved your hand vertically upwards and you moved your hand vertically downwards. Then only the wave was created on the rope. Then දැන් මේ rope එකට ඉස්සරලා කොහෙවත් energy එකක් තිබුණේ නැහැ. Right? What you did from your body, from your hand, you transferred energy into this rope by moving your hand vertically upwards and downwards. දැන් ඔයාගේ hand එකෙන් energy transfer කරා rope එකට. ඒ energy එක මේ rope එක දිගේ transfer වෙනවා මේ පැත්තට. දැන් කාගේ හරි ඇඟේ මේ rope එකේ end එක වැදුනොත් සමහරලාට එයාට රිදෙයි. Right? Energy from your body was transferred through the wave into another person. Now I can't ගහන්නත් පුළුවන් ඔය වගේ wave එකක් හදලා අපිට කසවල් වලින් කරන්න ඔය වැඩේනේ, right? So you obviously understand by this wave motion the energy is propagating through the rope from this end to this end. ඒක clear නේ? අමාරු දෙයක්. And the very important thing is, if you think about the particle from which you were holding this rope, දැන් මේ rope එක හැදලා තියෙන්නේ solid matter වල, right? You can understand this is a solid substance. මේ material medium එක solid state and it is made up of solid materials. So මතකයි solid materials වල atoms මාර ළඟින් tightly packed වෙලා තියෙන. If I can remind that to you very quickly, if you could remember, in solids the atoms were very tightly packed and there were minimum space among them. So this is what we call as a solid state. So rope එකේ තියෙන atoms වල නැත්නම් molecules arrangement එකක් like this, right? So in this case, ඔයා මේ rope එකට energy අතෙන් transfer කරනකොට ඔයා මොකද කරේ? rope එක අල්ලන තන particles එක moved vertically upwards and moved vertically downwards. හැබැයි the energy what you transferred from your hand to the rope propagated in this way. Can you see this? Your particle of this particle of the wave which you were holding into moved vertically upwards and downwards, and it is still on your hand, right? You're still holding into it. ඒක මේ wave එකේ propagate වෙන්නේ නැහැ. That the particle moved vertically upwards and downwards. ඒක මේ wave එකත් එක්ක ගියේ නැහැ. ඒක තාම ඔයා අල්ලගෙන ඉන්නේ. ඒක moved vertically upwards downwards විතරයි. But still the energy of what you gave to the rope by doing that motion මෙන්න මේ පැත්තට propagate වුණා. එහෙනම් හොඳට මතක තියාගන්න. දැන් මෙතනදී අපිට මාර ක්ලියර්ලි පේනවා අපි මේ rope එකේ create කරපු energy එක, right? අපි මේ rope එකට transfer කරපු energy එක propagate කරන්න හදපු energy එක rope එක දිගේ නැත්නම් solid material medium එකක් through propagate වුණා. From this end to that end. Between two concerned points අනිවාර්යෙන් මේ particle move වුණා. Sorry. Energy එක move වුණා. But the particles in the rope did not move. මේ particle මේක අල්ලන් හිටපු particle එක කොහෙටවත් move වුණේ නැහැ. That's very important. That's what it says. When a wave is propagating through a material media, even though the energy propagates from one point to another, the particles will not be moved within two concerned points. ඒ කියන්නේ wave එක යන පැත්තට particles dislocate වෙන්නේ නැහැ, right? ඒ කියන්නේ particles relocate වෙන්නේ නැහැ. ඒ කියන්නේ හිතපු තැන particle එක නැතුව වෙන තැනකට move වෙලා වෙන තැනක stop වෙන්නේ නැහැ. particle එක අනිවාර්යෙන් ඉන්න තැනම ඉන්නවා. So put up your hands if you could understand my explanation up to now. I just explained very few parts. All right. Okay. Anything to ask? If you have anything to ask, you can ask. Right. Anything to clarify? This is a very easy lesson which offers like somewhat a considerable mark in your paper. Okay, nothing to ask. Okay. The next important thing are our definition particles. What do you call it? It said it's a disturbance propagate through a material media, right? It's a disturbance propagate through a material media, right? Okay, explain, right? Now just imagine, hold on. For this, actually, we took some students in this class. We practically discuss. We took some students in the class and made this demonstration. Just imagine now, I have these three marker pens. Can you see that there are three colors? So these three marker pens in three different colors, right? Okay, I'll take another one. Which is blue. Right. So I have four marker pens in four different colors. So imagine these marker pens are four atoms, right? මේවා atoms හතරක් කියලා හිතන්න. So if you predict the physical state, your prediction has to be solid, right? Then atoms හතරක් මේ විදිහට ළඟින් locate වෙලා ඉන්නේ. If you can remember the way I demonstrated the solid matter, මෙන්න මේ වගේ, right? එහෙනම් atoms හතරක් මෙහෙම ළඟින් locate වෙලා තියෙනවා නම් මේ මම කතා කරන්නේ any material media which is in the solid state. Then, right, what I'm going to do is දැන් ඔයාලා දන්නවනේ solid material media වලදී particles කොහොමද හිතන්නකෝ if I highlight one of these particles, okay, hold on, like if I highlight one of these particles like this, right, if I highlight this one, this particular particle මේ solid material media එකේ ගැලවිලා කොහෙටවත් අමුතු තැන් වලට යන්න බෑ. යාට එහෙම යන්න බෑ. යාට fixed කොහෙවත් යන්න බෑ යාට. That is what the nature of solid materials, right? එතකොට මෙතන මේ තියෙන solid atoms වලට if I transfer an energy, like මේගොල්ලන්ට දැන් ලොකුට energy එකක් නෑනේ. If I offer some amount of energy, just imagine I'm offering some amount of energy into this black marker, this atom. So then it will do a motion like this. This is its original position. It will move into this side, and then it will move back again into this side, and then it will come back to the initial point. Could you see the motion? This particle, when I offer him an amount of energy, it will move into this side, move back again, and then comes back to initial position. This is the only motion that it can make when it is a solid material. You call this motion as an oscillation. What is it? Oscillation. So what this particle does, this particle from this position moves into this side, and comes back to the original position. That's what an oscillation. If I offer amount of energy into this red color marker in solid state, එයත් ඒ වගේ motion එකක් කරනවා. මෙතන fix point එකක ඉන්නේ කායර ගැලවිලා යන්න බෑ වෙන කොහෙටවත්. මෙතන ඉඳලා මෙහෙට move වෙයි ආය original position එකට. එතකොට දැක්කද මොකද වෙන්නේ කියලා? This red marker collides on this blue marker. This red marker collides on this blue marker. So then what will happen? The energy what I offered to this red marker, due to this collision of it with the black marker එකකට එයාගේ energy එක transfer වෙනවා. එහෙනම් මෙයා ඊට පස්සේ මේ වගේම motion එකක් කරනවා. එයාගේ energy transfer වෙනවා ඊළඟට. එයත් ඊළඟට එනර්ජි ට්‍රාන්ස්ෆර් කරනවා. දැන් එතකොට ඔයාලට තේරෙනවද මෙහෙම ස්ටෙඩි තිබ්බ ඇටොමික් අරේන්ජ්මන්ට් එකට අර වේව් එක ප්‍රොපගේට් වෙන්න ගියපම මොකද වෙන්නේ? මේ අරේන්ජ්මන්ට් එක වෙනස් වෙන්නේ නැහැ. හැබැයි අරේන්ජ්මන්ට් එක පොඩි ඩිස්ටර්බන්ස් එකකට සබ්ජෙක්ට් වෙනවා. දැන් මෙහෙම කාම් තිබ්බ අරේන්ජ්මන්ට් එක ටිකක් මෝෂන් එකකට එනවා. Right? Because these particles are going to be oscillating within the structure. ඒ oscillations වලින් එන collisions වලින් තමයි the next particle එකට එනර්ජි ට්‍රාන්ස්ෆර් කරන්නේ. And then if I ask a question from you, Benze, මම අහුවොත් when this red marker is transferring energy to the next black marker by the collision, මේ red marker එකට මම offer කරපු energy එක 100% black marker එකට transfer වෙනවද? එහෙමත් නැත්නම් මේ collision නිසා black marker එකට transfer වෙන්නේ energy loss එකක් එක්ක අඩු amount of energy එකක්ද red marker එකට තිබ්බට වඩා? What do you think? අඩු අනිවාර්යයෙන්. Because why මෙයා ඊළඟ collide වෙනකොට ওই collision එක නිසා මෙයා ගාව තිබ්බ energy එක lost වෙනවා ටිකක්. එතකොට මෙයා black marker එකට energy transfer වෙන්නේ පොඩ්ඩයි. එහෙනම් what you can understand. එතකොට wave එකක් propagate වෙන්න ගත්තාම limitless propagate වෙනවද? නැත්නම් wave එකේ energy degrade වෙලා ගිහිල්ලා ඒක neutral වෙලා energy propagation එක නැත්නම් wave එක disappear වෙන්න පුළුවන්ද? Shamaya නෙමෙයි කවුද මේ Susan, what do you think? Susan, what do you think? Susan, are you there?
Sorry, repeat.
Right, okay. මම අහන්නේ wave එකක් මොකක් හරි material medium එකක propagate වෙන්න ගිහුවාම එක particle එකකින් අනිත් particle එක collide වෙලා energy transfer වෙනකොට energy loss එකක් තියෙනවා එතන. ඒ කියන්නේ next particles වලට හම්බෙන්නේ කලින් particles වලට තිබ්බට වඩා අඩු energy එකක්. ඒ හින්දා wave එකක් limitless විදිහට transfer වෙන්න පුළුවන්. නැත්නම් energy එන්න degrade වෙලා ගිහිල්ලා energy loss වෙලා wave එක disappear වෙනවා. disappear වෙනවා. ඒ කියන්නේ දැන් when you talk you produce sound energy, right? When you talk you produce sound energy. ඔයාට පුළුවන් උගලගේ ඉස්කෝලේ ඉඳලා ගෙදරට හෙන්න කෑ ගන්න බෑ. ඇයි? ඔයා ජෙනරේට් කරන එනර්ජි එක පාටිකල්ස් කොලයිඩ් කරගෙන ඉස්සරහට යනකොට මොකද වෙන්නේ? At a place energy will be lost from at every transformation, at every transition of this energy from one particle to another particle, energy loss එකක් තියෙනවා. ඔහොම loss වෙලා ගිහලා at a point the energy will be very low. ඒ වගේ point එකදී ඒ තවත් ඉස්සරහට energy propagate වෙන්න බෑ, energy එක disappear වෙලා යනවා, dissipate වෙනවා, right? Okay, so then what you have to understand in waves disappears. Waves when propagating waves, sometimes the energy what you created at the beginning will not be transferred to the extent as it was, right? Okay, so these are the very simple things that you need to understand. මම අර කිව්වේ දැන් මේ වගේ atomic arrangement එකක් තියෙනවා in solid, but if I offer some amount of energy to this yellow color atom, it will collide, it will move into this direction, and then comes back to the initial position. Meantime එයා ඉස්සරහ තියෙන particle එකේ වදිනවා. වැදුනහම එන්නේ කහ පාට එක්කෙනා ගාව තිබ්බ energy එක transfers into the next particle, and then මෙයක් the second particle එකත් ඒ වගේ motion එකක් කරපුවම again the energy will be transferred into the third atom, right? Likewise the energy transfers on, right? This can happen in solid, liquids, and even in gaseous states, right? So due to this propagation of energy through a material media, ඔයාලට දැන් තේරෙනවා මේ arrangement එක smoothly මේ විදිහටම තියෙන්නේ නැහැ. අර energy එකක් transfer වෙන්න ගත්තාම what happens, the atomic arrangement or the molecular arrangement of the solid materials alters a little bit. So that's why you call, when propagating an energy, it is kind of a disturbance propagates through the material media. That actually it's a disturbance for the arrangement of molecules or atoms. That's what the definition says, something like that. Okay, right? So up to now, is it clear? Did I make anything like difficult for you to understand? So did you understand why do you call that it's a disturbance propagating through a material media for a wave? It says, the definition says wave is a kind of a disturbance propagates through a material media which carries energy. Because why energy, when the energy is carried by a wave through a material media, the atomic arrangement or the molecular arrangement actually alters a little, right? So that's why you call the disturbance propagates through material media when energy is transformed, when energy is propagates, it's called a wave, right? A part එක තේරුණාද? මම මේ කියපු part එක තේරුණාද කට්ටියට? Right? Shamaya, Suzanne එක තේරුණාද? Suzanne?
Yes, sir.
Okay. Prabodhya තේරුණාද ඒක? නිර්මාණි?
Yes, sir.
Eli එක තේරුණාද? Elisha, are you there? Was it clear to you?
Yes, sir.
Okay. Are you there? Are you actively there? Elisha, are you away from the device?
No, I'm here.
Okay. Upe, is it clear to you? Bima harida?
Yes, sir.
Okay, perfect. Right. Okay. So the next thing, let's go to the next part very quickly. Right. Okay. Wave motion. Okay, wave motion. Okay. So see it like this. So it says that the energy can be propagated. Now, when a wave is propagated through a material media, this point says the energy only propagates between two concerned points, but not the particles. That's what I explained from this rope, the wave what is created on the rope, right? Next part. When a water wave, now an example, okay? When a water wave travels on the surface of water, though the water particles move vertically up and down, they don't travel along with the water wave. The water wave එක energy propagate වෙන්නේ water surface එකේ horizontally, right? හැබැයි ඒ පැත්තට particles propagate වෙන්නේ නැහැ. Particles will be still at the same position, moving vertically up and down, right? Like what I demonstrated with the rope, right? Okay. Next part, wave motion. Okay. Below two are examples where the waves travel through certain medium. In one case, the wave transmits through the material medium of a rope, and the other is the wave that transmits through the particles of water. The motion of particles in each medium transmit energy in the form of a wave through the medium, even though the particles themselves do not move along with the wave. Okay. Sound waves propagate through air and also through liquids and solids. Okay, so that confirms us some waves can travel through all three physical states of matter. Right. Okay, next one. There are also waves that travel without any involvement of a material medium. Electromagnetic waves need no medium for the propagation. Right. Okay. So then we come across the classification of waves. Right. We come across the classification of waves. Simply, Lamai, the waves can be classified into two main parts depending on the way how they propagate. So if when you're talking about waves, they are classified basically into two, right? Waves are classified basically into two. How the waves which need a material medium for the propagation and the waves which does not need a material medium for the propagation. So waves which does not need a material medium for propagation are called EM waves. That means what? Electromagnetic waves. We call them as electromagnetic waves. What are electromagnetic waves? The waves which do not need a material medium for the propagation. Right. Okay. So simply in this flow diagram, flow chart, you can mention that. So electromagnetic waves, under this you can simply write very quickly the waves which do not need a medium for the propagation. The waves which do not need a medium for the propagation. Propagation into the medium waves, well, we call them as electromagnetic waves. So you can simply say them as EM waves. This is not hard, very easy. This is very easy. Lamai look what a easy part. Rocket science very easy things, right? Okay. So waves which does not need a medium for the propagation, you call them as what? Electromagnetic waves. Mechanical waves, obviously you can understand it. Mechanical waves, definition, the waves which need a material medium for the propagation, right? Sort of mechanical waves, the mechanical waves, right? Mechanical waves. Mechanical waves waves which needs a medium, waves which need a medium for propagation. Waves which need a medium for propagation. Waves which need a medium for propagation. Okay. Waves which need a medium for propagation. Hari. Then ape kattiya nana thanak, right? Okay. So when we say electromagnetic waves does not need a medium for propagation, sometimes in your question papers, they would question you, if they were given a medium, would they propagate through it? Right? The best example is sun rays, as I explained to you at the very beginning. Can you remember sun rays? දැන් ඔයාලා අහලා තියෙනව නේද ඉරේ ඉඳලා එනවා කියලා UV rays. හරිද? නිකන් හිතන්නකො මේ අපි කතා කරේ UV rays ගැන කියලා. UV rays are a form of electromagnetic waves. ඒ කියන්නේ එයාට vacuum එක through යන්න පුළුවන් because they don't need a medium for propagation. එහෙනම් sun එකේ ඉඳලා එන UV rays කියන්නේ what? They are a type of electromagnetic waves which does not need a medium for propagation. එයා අපේ atmosphere එක through ආවේ නැද්ද? ආවන්. එයා through ආවේ නැද්ද? ආවන්. වතුර යට හිටියනම් වතුරත් රත් වෙන්නේ නැද්ද ඔය waves නිසා? වෙනවනේ. ඒ කියන්නේ වතුර through යනවා, එයා through යනවා. ඔයා මොකක් හරි metal material එකක් තිබ්බොත් ඒක heat කරන්නේ නැද්ද? කරනවනේ. එහෙනම් ඒව through යනවා. එහෙනම් ළමයි what you understand, these electromagnetic waves, they do not need a medium for the propagation, but if you offer them a medium to travel through, ඒවා යනවා. සමහර කට්ටිය හිතන්නේ electromagnetic waves වල යන්න බෑ. අනිත් මෙයාට medium එකක් ඕනේ නෑනේ for the propagation. medium එකක් අස්සෙන් යන්න situation එකක් හැදුවොත් යන්නේ නැහැ කියලා. යනවා. Right? Keep it in your mind. Even if you offer an electromagnetic wave a medium for the propagation, එයා ඒක අස්සෙන් යනවා කිසි case එකක් නැහැ. Main example එක simply මතක තියාගන්න. Right? So these electromagnetic waves, why do you call them electromagnetic waves? They do not need the medium for the propagation. Material medium එක involvement එකක් ඕනේ නැහැ propagation එකට. But still, if you offer a medium, they could travel through that medium as well. Okay? So what are mechanical waves? Mechanical waves cannot propagate through vacuum. That means material medium එකක් නැතුව electromagnetic waves වලට යන්න බෑ. When you are in small grades, you should have heard if you talk in the space, nobody could hear because sound waves need a medium for the propagation. Sound waves වලට medium එකක් නැතුව propagate වෙන්නේ නැහැ. Space එකේ ගිහිල්ලා ඔයා space suit එකේ helmet එක නැතුව කාට හරි hi bye කිව්වට ඇහෙන්නේ නැහැ. Lip movement එක විතරක් පෙනේ. ඇයි sound propagation එකට there should be a material medium, right? එහෙනම් again sound කියන්නේ mechanical wave එක, right? So what you have to understand, mechanical waves are the waves which need the material medium for the propagation. ඒගොල්ලොන්ට නම් material medium එකක් නැතුව propagate වෙන්න බෑ. හැබැයි electromagnetic they don't need a medium for the propagation, but if you offer a medium they could travel through that as well. Keep that in your mind very strictly, right? Because you could be fake with MCQs options very easily with that. So then you should have gone through the classification, I think. So what does the classification says? Waves can be mainly classified or grouped into two as electromagnetic waves and mechanical waves. What are called electromagnetic waves? Waves which need a medium for the propagation. Sorry, electromagnetic waves, waves which does not medium for the propagation. What are called mechanical waves? Waves which does not, sorry, waves which just need a medium for the propagation. Medium එකක් ඕන එකක් mechanical waves, medium එකක් propagation එකට ඕනේ නැති කට්ටිය electromagnetic waves. That's a simple classification. And then guys, what you have to understand is we further classify these mechanical waves. Okay, we further classify these mechanical waves. Okay, we further classify these mechanical waves as transverse waves and longitudinal waves. Okay, right. Then for the longitudinal waves and like transverse wave, you need a medium for the propagation. As solid නැත්නම් liquid නැත්නම් gaseous medium එකක් අනිවාර්යෙන් propagation එකට you need. Okay, right. So how are these things classified? Then material medium එකක් වුණු ඔක්කොම waves වලට we call them as mechanical waves. Mechanical waves further classified into two as transverse and longitudinal. How is this classified? How are these two waves classified? It actually depends on the way of the motion of the particle versus propagation of energy of the wave, right? So mechanical waves can be further classified depending on the motion, depending on actually the direction of the motion of the particles versus the energy propagation direction. එතකොට mechanical waves classify කරගන්න පුළුවන් further into two by considering two factors. Actually the two factors are the direction of the motion of the particle versus the propagation direction of the energy, right? So if you simply talk, I'll just brief it here because we have to talk about it in detail when we talk about specifically about mechanical and when we specifically talk about longitudinal and transverse wave, we have to talk about in this lesson. We will be talking them about in detail, right? So then I'll just brief it over here, right? So when you talk about this transverse wave, mama create karapu rope ekake create karapu wave is an example for a transverse wave. Okay, so what is it? If you could remember when the rope was when I create the energy on the rope, by making a wave motion, could you remember that particle which I was holding the rope? That particle actually moved vertically upwards, then came back downwards, and then came back to initial position. This is the motion of the particle. So we can mention particle movement. Okay, this is particle movement. You do okay, particle movement. Okay, particle movement. Okay, and then into which direction the energy was propagated? This direction. Energy propagation. What can you see here? The movement of the particles and then the propagation of energy, the two directions are perpendicular to each other. Isn't it? Right? So this is not a graph actually, right? Don't make it as a graph. So I just wanted for you to see the directions of the oscillation of particles and the direction of the propagation of the energy. එතකොට මේ this is a mechanical wave. Transverse is a mechanical wave, which means needs a medium for the propagation. But during the propagation of energy as a transverse wave, the particles in the medium will be oscillating vertically up and down. Meantime, the energy propagates perpendicular to the motion of the particles, right? So particles oscillation direction perpendicularly තමයි energy propagate වෙන්නේ. Yeah. That is how you identify transverse waves. So we can just put a note here. Okay, we can just put a note here. Particle oscillation direction, right? Particle oscillation direction and wave propagation, energy propagation, and the energy propagation direction and energy propagation direction is perpendicular to each other. අපි මේවා ගැන කතා කරනවා when we talk about these waves in detail. දැන් හැබැයි මෙතන හරි proper idea එකක් එකයි යන්න. එහෙම නැතුව බෑනේ. ඒ හින්දායි මම මෙතන දුන්නේ ඔයාට. Right. So transverse waves, right? You can write, right? මෙතන ලියා ගමු ගොඩක්. දැන් ඔයාලට මම දන්නා සමහර ඒවා පේන්නේ නැහැ. මම explain කරන්න. Don't worry about it, right? So under transverse wave you can write this very short. ලියා ගන්න. Right, transverse waves කියන්නේ මොකක්ද කියලා පොඩි description එකක් ලියා ගන්න. Right, මේ diagram එක හදා ගන්න. Transverse wave එකක් කියන්නේ මොකක්ද කියලා. The rope thing situation, right? So you have created a wave on a rope. The particle moves vertically up and down. You can mention the particle movement and the energy propagates through the wave into this direction, energy propagation direction. Mark them first under the classification. So then I'll just give you the description. All right. What to be written here? Particle oscillation direction and the energy propagation direction is perpendicular to each other. Particle oscillating direction and energy propagation direction is perpendicular to each other. Okay. Right, let's quickly talk about this longitudinal wave. So there are particles involved in transverse particle oscillation direction and the wave energy propagation direction are perpendicular to each other. So let's talk about sound waves. Okay, when you talk about sound waves, it's like this, right? So when you talk about sound propagates majorly through air and human. It can travel through it can travel very fast, extremely fast in solid media, right? Then in air, right? When you talk about propagation of sound through air, like you know that the air particles are like evenly distributed in the atmosphere. So when you talk, your vocal cords produces sound, and then that it actually produces a vibration, right? So you give effort to your vocal cords, and then your vocal cords are surrounded by air in your larynx, lower larynx, right? When you give an effort into your vocal cords start to vibrate, and then the air particles surrounded by this vocal cord will also be vibrate. That vibration comes up all the way to your buccal cavity, gets modulated by your teeth, lips, upper palate, lower palate, and the tongue. And then those vibrations will be released to the atmosphere. Then the air particles start getting collided with your air particles, which is released with a vibration from your buccal cavity, right? So then the air particles in the atmosphere, if I talk about one of these air particles in the atmosphere, such an air particle like this, it actually moves forward, comes backward. Okay, I'll just mention the motion. I could even mention it over here as well. So this particle actually moved vertically upward, came all the way vertically downward, and then came back to the initial position. That's what it happened, right? So you could even mention this thing when you're marking the other part, okay? right? So then what happens here? These air particles moves into this direction, comes back all the way into backward direction, and then comes back here. When this particle moves forward, moves backwards, and comes back to initial position, while on this motion, can you see if there was another air particle which was in front of this one, right? This, due to the motion of this yellow color air particle, the blue color air particle gets collided. So due to that, it will also show a similar motion like the yellow one. Moves forward, moves backward, and then comes back to the initial position. So on, the particles will be colliding continuously, right? When I talk, the air particles in front of my buccal cavity will be colliding with the air particles what I release from the buccal cavity with some sort of a vibration, which means some sort of an energy. So these air particles moves vertically, moves forward, moves backward, and comes back to the initial position. That's what simply happens. During this motion, when it moves forward, basically all the air particles which are in front of this motion of the air particle gets collided, and they move. So in which direction the sound propagates? Sound propagate this is the propagation of energy. Energy propagation direction. Energy propagation direction. And what was the particle oscillation direction? This part this is particle oscillation direction. Particle oscillation direction. Okay. So if you can see, wave propagate in direction, particles oscillate in direction, they come parallel to each other, right? So in this case, the wave propagation direction and the particle oscillations were perpendicular. Those two activities were perpendicular to each other. The two activities were perpendicular to each other. But in this situation, the wave propagation direction and the particle movement is parallel to each other. So that's why we call them as longitudinal, right? So that's how they are classified. They may deන්නටම movement එකට propagation එකට material medium එකක් කොහොමද? Of course they need a material medium. So why do you classify again into two? By depending on the wave propagation direction versus the particle movement. May transverse wave propagation direction එකට particle movement එක perpendicular. In longitudinal waves, wave propagation direction එකට particle movement එක parallel. Now parallel wave propagation එකත් මේ පැත්තට particle movement එකත් මේ පැත්තට. Keep in mind, this particle, though it moves a little forward, it doesn't move along with the wave. There are කහපාට particle එක බලන්න started the motion from initial point, move forward, move backward, and came back to the initial point. Now that it has moved very forward, right? I hope you can see it as yellow, right? So keep in your mind, these particles just not the main energy ka yana direction එකට ඒගොල්ලෝ ගැලවිලා විශ්කලා යන්නේ. Keep in mind, this particles moves only for a short distance. It moves backwards and comes back to the initial position. Keep it in your mind, right? So don't ever misunderstand that the particles in the material medium travel along with the energy propagation. No, it does not happen. Quickly go for this diagram. I'll just then show you a video to explain how actually this happens by using a slinky, right? I'll just give the description also. Tagal diagram එක දාගන්න. Right. Hope you're done with that. So I'll be moving. Right. Okay. Let's quickly write. To describe this part, particle oscillation direction. You could even write on your own. Particle oscillation direction. Particle oscillation direction. And the wave propagation direction is parallel to each other. Particle oscillation direction and wave propagation direction are parallel to each other. So now you should be able to understand how these waves are classified. So particle oscillation direction and the wave propagation direction, energy propagation direction are parallel to each other. All right, now I think you have a clear picture how these waves are classified. So the mainly waves are classified into two, depending on the necessity of material medium for the propagation. So if the wave needs a material medium for the propagation, we call those sort of waves as mechanical waves. If the wave does not need a medium for the propagation, we simply call them as electromagnetic waves. The point to keep it in your mind, even though the electromagnetic waves offer a medium for the propagation, we could even easily travel through a medium, though doesn't need a medium for the propagation, right? And then when you talk about mechanical waves, they are further classified into two, depending on the particle oscillations, and then direction of the energy propagation in the wave. So if the particle oscillation and the energy propagation directions are parallel to each other, we call those sort of waves as transverse waves. And particle oscillation and wave for energy propagation directions are parallel to each other, we call those sort of waves as longitudinal waves. That's what it is, right? So we are moving forward for the next part, right? So I could simply show you this diagram to make you more understand with the particle movements and all these energy propagation directions, right? So simply this, you should have seen it, right? Making a spring, these things are available as a toy as well. Make it a slinky, right? Vincent එකක් අරන් තියාගන්න ඇති උහේ අනිවාර්යෙන් මේ මාර පොට් මේවා මේ ඒ කියන්නේ ටිකක් හොඳයි මේවා දේවලින් ගොඩක් දේවල් කරන්න පුළුවන් ඒ කියන්නේ සෙල්ලම් කරන්නත් පුළුවන් මේ type you can demonstrate wave motion with this, right? හරි මේවා මරු, right? Okay, see here, so longitudinal wave එකක් පෙන්නන්න මම ඔයාලා මේ ඔන්න අත ඉස්සරහට move වුණා පිටිපස්සට move වුණා right? So the particle oscillation, see here, particle oscillation is into this direction and into this direction, okay, into this direction, these two directions, right? Wave එක යන්නේ කොයි පැත්තටද? Wave එක යන්නේ that's why we call them as longitudinal waves, right? Okay, simple. And the next part, okay, all right, okay, see here. Now in this case, do you see the motion of the hand? The hand moves vertically upwards, vertically downwards. Meantime, the energy propagates through the wave into this direction. So these two actions are perpendicular to each other. So we call them as transverse waves, right? Simple, very simple, right? Okay. So then we are moving further through the discussion, right? So we are going to talk about mechanical waves, right? A slinky can be used to understand the wave motion of a mechanical wave, okay? Slinky is the thing what I just showed you. ඒක තමයි slinky එක කියන්නේ. Just hold on for a second, right? Okay. The next part. Waves that need a material medium for the propagation are called mechanical waves. We already know it by the classification. So waves form on water, sound waves travel through air, waves forms on a guitar string when plugged. When you're strumming a guitar, the waves created on the string are mechanical waves, right? Even the sound waves propagate through air, these mechanical waves as well, right? Okay, next part. Based on the direction of the motion of particles in the medium and the motion of the waves, mechanical waves are classified or grouped into two. That's what we just learned, right? Okay. So transverse waves. Waves propagate in the direction perpendicular to the direction of the movement of particles in the medium are called transverse wave. We already know it, so then highlight it. Highlight it. So if you have a wave which needs a medium for the propagation and the particle oscillation in that medium is perpendicular to the direction of the motion of particles, you call them as a transverse wave. Okay, right. So then there is a very important part that you need to learn about this transverse wave, which your teachers might have taught incorrectly in your school, so that I'm going to correct it, right? Okay. So as Vincent said, in whatever the type of a wave, when the energy propagates through a material media, but atoms, molecules collide, when there will be an energy lost. So due to that, the wave energy that a wave carries degrade, and the wave could disappear, right? So I'm going to demonstrate the particle motion. I'm going to demonstrate the particle motion of a transverse wave, right? Okay. For that, I'm taking this diagram. So we have a line like this. Okay. We have a line like this. We have a line like this. We call it as the zero displacement line. Okay. We call it as the zero displacement position. Okay. I'll tell you, zero displacement position. Okay. Zero displacement position. Okay. So which means if you have any particles over here, this particle here is not displaced simply. The particle, if it is on the line of zero displacement position, that particle has not displayed at least an inch in a zero displacement position. Okay, so we had to talk about transverse waves. So if this particle moves vertically upward, vertically upwards, I should be very sharp in this, right? Okay. So if this particle moves vertically upwards, okay, it moves vertically upward and then it comes back, then moves vertically downwards and then comes back here. Okay, hold on. Okay, right. So then it moves like this and then comes back here, right? Did you see that? The particle moved vertically upwards, a particle moved vertically upwards, then it moved vertically downwards, and then it came back alone, it came back again to the zero displacement position. This is how the motion of a particle will be. Now, the next thing, when this particle moves like this, at the end of the motion of the particle, the energy will be transferred into the next particle. Okay, next particle, right? So you have the next particle. Okay, next particle. Now keep it in mind, these particles are bonded very tightly. Yeah? Then this particle also moves vertically upward. Now I will just not take the position of this particle as high as the previous particle, because as Vincent said, when this particle collides on the second particle, the energy will be lost. So then I will just mention it like this. Okay, so it's the motion of the wave is much shorter than the previous one. Okay, right, that particle also does the same thing, moved vertically upward, moved vertically downward, and then came back to the initial position. At the end, it then transfers this energy into the next particle. So you have the next particle, it also does the same thing, moves vertically upwards, moves vertically upwards, moves vertically downwards, moves vertically upwards, then moves downwards, and then comes back to this initial position. Okay, right. So I'll just mark the motion of the particle. Right, simple. Why did I decrease the height? Because the energy gets degraded. So that's why I decrease the height of the motion of the particle's displacement. Right. So I think simply you can understand this concept. Then you might have a problem. Particle particle energy transfer, how that happens, right? Then you might be wondering, right? Okay, party that other situation you'd be okay. Like if you could remember the longitudinal waves, particle move පස්සට move වෙලා ආයෙ මෙතෙන්ට එනවා. ඒකෙද your crystal clear, you can definitely understand මෙයා ඉස්සරහට move වෙනකොට ඊළඟ තියෙන particle එකට ඩෝක් ගාලා වදිනවා. එතකොට මෙයාත් ඉස්සරහට move වෙලා පිටිපස්සට move වෙලා ආයෙ මෙතෙන්ට එයි, possible, can understand. But the question is මේකේ කොහොමද particle එක උඩ පල්ලෙහා ගියාට පස්සේ ඊළඟ particle එක move වෙන්නේ? Keep it in your mind, these particles are tightly bonded. So if you just imagine now, imagine there's a line, a human line, right? A human line holding their hands, not so long, කොටා කරලා අල්ලන් ඉන්න කියන්නේ මෙහෙම දිග ඇදලා නෙමෙයි short කරලා. And imagine one person goes down, දෙපැත්තෙන්ම දෙන්නෙක් අල්ලගෙන ඉන්නේ, one person goes down very low, you pull very low, what would happen to two people on either side of you? Those people also will not totally come down as you, but they will be pulled downwards. Can you understand? What if you try to fly up? Those two people also would come up, right? So these things, that is what the thing happens here as well. These particles are tightly bonded to each other because of this motion. When it moves up, and when it moves up and when it comes down, this particle will also initiate a motion due to the motion. Why does it start to move up? Because I have offered him an energy. Somebody has offered him an energy. So because of that, and a motion will be initiated. When it moves vertically upwards, second particle move upwards. Why? Because as I explained, ඔයා වල්ලන් ඉන්නවා දෙපැත්තෙන් කවුරු හරි දෙන්නේ. ඔයා පල්ලෙහාට ගියොත් අර දෙපැත්තේ ඉන්න උන් දෙන්නට පල්ලේ ඒ ඉන්න විදිහට ඉන්නත් බෑ. ඇයි ඒ දෙන්නවත් පල්ලෙහාට යනවා. Right? That නිකන් ඒක උඩට ඉමැජින් කරලා බලන්න කොනේම ඉන්න එක්කෙනෙක් පල්ලෙහාට යනවා. next particle එක automatically පල්ලෙහාට යනවා. එහා පැත්තේ හල්ලන් ඉන්න එක්කෙනා ඒ link එකත් මොකද චුට්ටක් හරි පල්ලෙහාට යනවා. Right? ඔයා උඩට ගියොත් එහා පැත්තේ එකක් පොඩ්ඩක් මිස් වෙනවා. next particle එකත් එහෙම මිස් වෙනවා. That's what simply happens, right? So these particles moves vertically upwards, downwards, comes back to the initial position and hands over the energy to the next particle. It also moves vertically upwards, downwards, and then comes back to the initial position. Likewise, the thing happens, right? Okay. හැබැයි energy propagate වෙන direction එක මොකක්ද? මේ particle motion එක මේ පැත්තට energy propagate වෙන මෙන්න මේ direction එක. I'll just mention. This is what the energy propagation direction. You need to don't draw it. I'll just mention it to you where to draw it. Right? Energy propagation direction. Okay. And then your teachers might have said you, this whole semicircle is called a crest. If it is, that's wrong, eh? Right? Your teachers might say this. Now maybe ඇත්තටම particle එකේ movement එක elaborate කරලා තියෙන්නේ, right? Then okay, before that I'll just explain it and come to that part, right? So if your teachers in a school or wherever, if they told you if this half cycle is called a crest, that's very wrong. That's very wrong, eh? Crest is a position, guys. Crest is a position. Can you see me? Crest is a position. So I would just pan it to this side a little bit, right? Okay. So this is crest actually. I hope you can see this position. This position, exact position. This is the maximum. This is the maximum upward displacement position. So this position is the maximum distance, that displacement that this particle can travel from the zero displacement point. So this position is the maximum upward displacement position. You call that as the crest. You call that as the crest. So your teachers very carelessly says this whole half cycle is the crest. Or you understand it in a wrong way that this half cycle is called the crest. No, that's wrong. Very wrong. That's very wrong. Crest means it's a position. Or half cycle crest. Crest is a position. What is the position? Crest means the maximum upward displacement position that the particle can reach in a transverse wave. එතකොට මෙතෙන්ට කියන්නේ ක්‍රෙස්ට් තමයි. ඉතින් මේ පාටිකල් එකට යන්න පුළුවන් maximum upward displacement position එක මේකනේ. මේ පාටිකල් එකට යන්න පුළුවන් maximum upward displacement position එක මේකනේ. එහෙනම් you call all these points as crests, right? And what is this? What is this? This is the maximum. This is the maximum downward displacement position of the particle. So you call that as the trough. You call that as a trough. So if you have understood this whole semicircle which is on to the downward direction is called that. This whole thing is called a trough. That's very wrong, right? Trough is also a point, is a position of the particle which it could be maximum displaced into the downward direction. So keep it in your mind very thoroughly, very strictly. These positions, crest and the trough are two positions in transverse wave, not two semicircles, right? එතකොට crest එකක් කියන්නේ the maximum upward displacement position that a particle can reach from the zero displacement line, and the trough is a point, is a position that a maximum downward displacement position that a particle can reach from the zero displacement line. So I want you to copy this over here, right? This, I think I should have kept space for you to copy down it over here. So I should have moved it, shift this one a little bit onto your right hand side, move, right? So you should have enough space over here to copy this down. Copy it very quickly, right? What's on the board, right? So you need to understand these two positions of these particles, right? The crest and the trough. Where particle clear? The Elisha, was it clear to you? Right? Okay. So let's quickly rush through this. Particles A and B have traveled the maximum displacement up in the upward direction. Such points in the wave, transverse wave, is called crests. So as you can see, A and B are the place. A and B, the position of those two positions in the wave are in the maximum upward displacement position. So we call them as crests, right? But the CD, those are the two maximum downward displacement positions. So you call them as troughs, right? Okay. And then we are moving into the longitudinal waves, right? Okay. Waves in which the particles of the medium oscillate parallel to the direction of the wave propagation are known as longitudinal waves, right? Okay. Read it again. Waves in which the particles of the medium oscillate parallel direction to the wave propagation are known as longitudinal waves, right? You know it, right? Okay. And then you don't have to talk much about this longitudinal waves. So then I'll just explain a simple thing for you to know about this longitudinal waves, right? Like this, okay? So if you go to the next part, right? They are also, I would just draw a line like this to indicate the direction of the propagation of the waves. කලින් වගේම direction මේ අද ඉඳන් line එකක්. I'm going to indicate the energy propagation direction with this. Energy propagation direction. Okay. And then if I talk about one particle, මම particle එකක් කතා කරනවා. මෙන්න මේ particle එක, it moves forward, then moves backward, and then comes here. මේ forward motion එක, මේ backward motion එක, මේ ආයේ initial position එක. මේ motion එක වෙනකොට if it collides usually on the next particle. එතන next particle at forward motion එකක් කරනවා, backward motion එකක් කරනවා, ආයේ initial position එකට එනවා. හැබැයි මම අර කලින් එකේ වගේ ගොඩාක් දික් කරන්නේ නැහැ මේ energy මේ wave එකේ displacement එක, because I just want to state that the energy is some amount of energy is lost during the collision of these two particles, right? අපිට කායි කාන්දේ ඉන්න clearly අදින්න ඕනේ නේද මෙහෙම. ඒක දිගට කරලා ගන්නවා. Okay. Okay, forward, backward, and again forward, right? So the next one, during the collision, some amount of energy loses, energy is lost. So then the displacement is shorter than this, right? Okay, forward, uh, backward, forward, right? So direction, this is the energy propagation direction. So this is the particle oscillation direction. Particle oscillation direction. Okay, so this is what simply happens in a longitudinal wave, right? So when the particle moves forward, the next particle gets collided, and then that particle also tries to move forward and backwards and comes back to initial position. Quickly note this down also. Oh, hold on. I want to mention two positions of this part also, right? Make it for the points to mark note, right? Okay. So if you could see here this spot, this exact spot, point, this is the maximum forward displacement position of the particle. That doesn't come up with a name, but it can maximum forward displacement position. Maximum forward displacement position. Okay, that is the maximum forward displacement position. Make a මොකක්ද එතකොට? This is the maximum downward displacement position. Okay, this is the maximum forward displacement position, this, and this is the maximum downward displacement position. This is the initial position. Initial position. That is called the zero displacement position. Zero displacement position. එතකොට particle එක ඉන්න තැන අර original ඉන්න තැන ඒකට තමයි කියන්නේ zero displacement position නැත්නම් initial displacement position. particle එක maximum ඉස්සරහට ගියපු තැන ඒක තමයි maximum forward displacement position. ඒ කියන්නේ particle එක maximum පිටිපස්සට ගියපු spot එක එතන තමයි maximum backward displacement නැත්නම් මේ downward නෙමෙයි maximum backward displacement position එක. downward නෙමෙයි, I'm sorry, maximum backward displacement position එක. Okay, very simple. Quickly note them now, right? So you have the made transfer longitudinal wave energy propagation direction particles move forward, backward, and comes back to the initial position. Particle original zero displacement position. May particle zero displacement position May particle zero displacement position maximum forward displacement position maximum down backward displacement position right? So very simple. Baga Pascal. See here. So you need to answer me. See here for a little while, right? So if now when you're talking about this longitudinal wave, see here very carefully. I have this particle, okay? So we are going to talk about few situations. So we're going to talk about few situations. So very be very careful, right? Okay, right. So this particle moves forward, comes backward, and then moves again back to the initial position. That's what simply happens. Particle moves forward, comes backward, and then comes back to the initial position. That's what happens. Forward, backward, initial position. Right. So this while on this motion, can you see very clearly while on this motion, this particle collides with the next particle. This particle collides with the next particle. So now imagine the situation. Just imagine the situation of this forward motion of the particle and predict, just visualize the exact point where this white color particle collides on the yellow color particle. So think of this region at that situation. Okay, once again. So this white color particle moves forward, comes backward, and then comes back to the initial position. That's what the motion, nature of the motion of this white color particle. So I'm asking you to think about the exact point, exact situation where this white color particle moves forward and at the situation where it collides the yellow color particle. So at that point, can you see in this position, in this frame, in this limited space, you have two particles. That means the white color particle which moved forward when it is colliding on the yellow color particle, this region has two particles. Can you see that? And that's one, that's number one. What I am asking you to imagine is the point, the exact situation, exact time frame where this white color particle collides the yellow color particle. In that position, that situation, make space එකේ you have two particles. Particle concentration මේ වෙලාවේ දැන් නිකන් imagine කරන white color particle එකේ movement එකක් නැහැ. In this situation now you have within this frame you have only one particle. Yellow color particle එක විතරනේ තියෙන්නේ. And what am I asking you to think is the motion, the situation, the spot exactly where white collides with the yellow color. එතකොට yellow color particle. එතකොට in main region you have two particles. That means the particle concentration is high. So such positions in the wave propagation, in the wave, such position which with more number of particles, with more concentration of particles are called compressions. We call them as what? Call them as compressions. We call them as compressions. Now, situation 2. Imagine what would happen to these two particles after the collision. Now, what would happen to these two particles after the collisions? Right, okay. Now the white color particle moved forward. Okay, it moved forward. It was the forward motion of this particle, and then it collided with the yellow color particle. Okay, right, yellow color particle. Now what happened? I'm marking the region. Okay, you had two particles, so this sort of a region in a way is called a compression because you have more particle concentration over here. Now, in the next step, what would happen? Because of the collision, some amount of energy carried by the white particle will be offered to the yellow color particle, and as a result, the yellow color particle will start to move forward. What would happen to the white color particle? It will move backward. That's what simply happens. So see here, after collision, the white color particle has to move backward, and then what would the yellow color particle do? It will also move forward. It will also move forward, and then what you could see here, you could see nothing. Right? You could not see anything here because why? The white color particle is now on the way of its backward motion. The yellow color particle is now on the way of its forward motion. Now in this area is lack of particles. The particle concentration is less. So such an area is called a rarefaction. Is called a rarefaction. Okay. Now I wanted to learn one more thing. Where would the rarefaction occurs? In the same place where the compression occurred. Now, right? After the collision, now at a point where these two particles collide, yellow was steady, the white one was moving forward, collided on the yellow. At that exact point, you have two particles in the region. You call this area as a compression. After a second, now not after a second, after a split of a second, the yellow moves forward, white moves backward. Now the same region is lack of particles. You call it rarefaction. Put up your hand, those who understood the concept. Right. So sound waves, longitudinal waves, propagate when through a series of compressions and rarefaction. I'll show you that. Right. See here. With the same video we just experience, we can clarify it further. See here. Now see. Okay. All right. Now think. The hand was moved forward. Now can you see in this area? Hold on. In this area, now I'm asking you to think about this area. In this area, the particle concentration is high because why? Can you see a lot of windings are found here? So compared to any other regions, this area has more particle concentration. So this is a compression now, right? So particles are moving forward, and now you have a compression here, right? And now afterwards, in the next second, what would happen? The hand would move backward. Okay. Now see what would happen. Okay. Now what happened? The compression was here in the region what I have marked 2 arrows in red. And now the hand moved backward. Now what could you see about this region? Now what could you see about this region? Now this region is lack of particles. You call it a rarefaction. So what happened to the compression which was here? It actually moved forward. It moved forward. Now here is a compression. And the place where the compression was now a rarefaction. Now see what happens next. What happens next? Okay. Okay. Now this region is what? Again, that region which was having a compression now has a rarefaction. Now මෙතන මොකද ඉස්සරලා තිබ්බේ compression එක. Sorry. මෙතන තිබ්බේ ඉස්සරලා compression එක. දැන් මොකද මෙතන තියෙන්නේ? Rarefaction එක. compression එක move forward. So හැමතිස්සම compression එකක් තිබ්බ තැන ඊළඟට create වෙන්නේ rarefaction එකක්. compression එකක් තිබ්බ තැන ඉස්සලා wave එකෙන් create වෙන්නේ longitudinal wave එක compression එකක්. ඒ compression එක ඊළඟ step එකට ඊළඟ position එකට යනවා. හැබැයි compression එක තිබ්බ තැන rarefaction එකක් තියෙන්නේ දැන්. Right? So longitudinal waves are propagating through material media as a result of series of compressions and rarefactions. Compressions and rarefactions series එකක් එක්ක තමයි longitudinal waves point එකක ඉඳලා point එකකට propagate කරන්නේ ඒගොල්ලන්ගේ energy එක. Was it clear to you? If it was clear to you, put up your hands, please. Okay. All right. Perfect. Right. So let's quickly read through this. We are done for the day. Right. So we have this make a කරන්න ඕනේ right. මේ summarizing කරන්න. Compressions are formed when the slinky is pushed forward, and the rarefactions occur when the free end of the slinky is moved backward. As a result of this wave propagation along the slinky, compression is the pushing together of air particles, and the rarefaction is moving a part of air particles from each other, air particles or whatever, right? So whatever the particles, if they're pushing towards each other, a compression is called compression is created when the during the particles are moving away from each other. A particle concentration less area is created, which is called a rarefaction. So then I just want you to summarize the difference and similarities of these two waves. Actually, we'll be summarizing the differences between each other of these two waves quickly. But divide this space into two and then write transverse and longitudinal on either sides. Right. On the left hand side, you can write transverse, and on the right hand side, you can write longitudinal. Quickly go for that. Right. Okay. Then you can write for the transverse wave, particles move perpendicular to each other. Sorry, particles move perpendicular for the transverse wave. Particles move perpendicular. Particles move perpendicular. Particles move perpendicular to the direction of the energy propagation. To the direction of the energy propagation. Particles move perpendicular to the direction of the energy propagation. Particles move perpendicular to the direction of the energy propagation, right? Right in front of that for longitudinal waves, right in front of that for the longitudinal waves, particles move parallel to the direction of the energy propagation of the wave. Particles move parallel to the direction of the energy propagation of the wave. Particles move parallel to the direction of the wave, energy propagation of the wave. Particles move parallel to the direction of the energy propagation of the wave. Okay, so we wrote descriptions for the two waves transverse. We wrote particles move perpendicular to the direction of the propagation of energy of the wave, and then we wrote for the longitudinal wave, for particles move parallel to the direction of the energy propagation of the wave. Right. So then once again, the next point under transverse, right? Wave propagates along the surface of solids, liquids, or strings. Right. Wave propagates along the surface of solids, liquids, or along strings. String instrument play කරද්දි ඒ strings වල create වෙන්නේ transverse wave. හැබැයි ඊට පස්සේ ඒ energy එක එයා වලට transfer වුණාට පස්සේ energy එක යන්නේ sound එකක්, ඒක longitudinal wave එකක්. Right. Okay. So wave propagates along the surface of solids, liquids, or along strings. You can write some examples. Water waves, vibrations created on strings. Two examples: water waves, transverse voltage, water waves, and then vibrations created on strings. Right, perfect. And then you can write the next part for the longitudinal waves. Next part for the longitudinal wave. Propagates through solid, liquids, or gases for the longitudinal waves, just in front of the point what we just wrote under longitudinal waves. Wave propagates through solid, liquid, or gases. Wave propagates through solid, liquid, or gases. You can simply write as the example, right? Sound waves as the example. Sound waves, right? So that's it